Okay, find this warm-up in your packet. Sorry, it doesn't have a page number, so it's after page 6, but before page 7. And we are going to pause the video here and give you about 5 minutes to answer all 7 questions. Okay, for number 1, you should think 4 to what power equals 64? And that is 3. For number 2, you can even write some work if you want. 3 to what power is 1/9? And then I need both sides to be a base of 3. So this is 1/3 squared. And then move that out of the denominator, so the power is -2. Eight to what power is 16? So for number 3, I'm going to make both 8 and 16 a base of 2. So now that the bases are the same, I can say 3 times what power equals 4. So the what power is 4/3. And then last but not least for 4, for this set at least, 5 to what power is 1/125. 125 is 5 to the 3rd, and since it's in the denominator, -3. Estimate and justify your answer. So for number 5, this is saying 2 to what power is 9? Well, 9's not even an even number, so that I don't know an exact value for that because it's no calculator. So to start, let me list out my powers of 2. And I can see that 9 is between 8 and 16. So log base 2 of 9 is somewhere between 3 and 4. So that log is somewhere between 3 and 4, since 2 to the 3rd is 8 and 2 to the 4th is 16. It's closer to 3 because 8 is closer to 9. Let's try 6. 4 to what power is 17? Well, I know 4 squared is 16, and 4 to the 3rd is 64, so it must be between 2 and 3, but closer to 2. So I'm going to say between 2 and 3, but closer to 2. And then number 7, 25 to what power is 4? Well, I know 25 to the 0 is 1, and 25 to the 1 is 25. But let's get a little more specific. I actually know 25 to the 1/2, because that's the square root of 25, is 5. So I'm going to say that number 7 is between 0 and 1/2. And it's going to be closer to the 1/2 since 4 is closer to 5. Okay, so now turn to page 7. And yesterday we did the what power function. I think that was yesterday. So we can see that an exponential and a log function are inverses of each other. They undo each other. So if I input 3, 2 to the 3rd is 8, but then if I take the log, so log base 2 of 8, 2 to what power is 8? That's 3. Logarithms can be defined for any base for an exponential function. Base 10 is the most popular. So anytime you write log base 10, we write that without the base. So log of 10 is 1. Log of 100, saying 10 to what power is 100 is 2. You can add at the bottom, log base 10 is the most common logarithm, and therefore we do not write the base 10. It is known that log with no base of x means there is a base 10. It's the same as when the square root of x has the little invisible 2 as the index. We can pause the video here for you to write that down. Okay, page 8. We are going to place A, B, C, D, and E along our number line. My explanation is going to be my evaluation of each term. So we're going to pause the video for less than a minute for you to evaluate these 5 logarithms. Okay. 3 to what power is 3? You should say this A is 1. 3 to what power is 9? 3 to what power is 1/3? 3 to what power is 1? And 3 to what power is 1/9? So along my number line, we've got E, C, D, A, and then B. And my explanation is my evaluation. Okay, we're gonna continue. We're gonna pause the video for about 4 minutes. You do numbers 2, 3, and 4. So finish this page. Okay, so your evaluations in number 2, you should get log base 3 of 81 is 4, log base 10 of 100 is 2, 1, 2, and 5. So since B and D are equal, they both go at the 2 spot, C, E, and A. All right, for 3, 1, 1, 0, and 0. A, B, C, D. And last but not least for 4, -2, -3, -3, -1. A, oh, you can add -3 over here, B, C, and D. Okay. Page 9, we're going to continue. So keep going. We'll pause the video, give you about 5 minutes to do page 9, then we'll go over the answers, and then we'll go to 10. Let me fill in the easy ones here. Okay, so then for 5B, 2 to what power is 16? That's, let's see, so 2 to the 4, well, 2 to the 3rd is 8. Oh, 2 to the 4 is 16. Now C actually takes some work. 8 to what power is 16? So that's 2 to the 3rd and 2 to the 4th. So this is 4/3, which is a little more than 1. So let's see. D, A, B. So 4/3 is 1 1/3. So put that here and put C. For A, 2 to what power is 5? So that's going to be between 2 and 3, but closer to 2, because now this I actually need an explanation for. Log base 2 of 5 is between, like 2 squared is 4 and 2 to the 3rd is 8. So that's between 2 and 3, but closer to 2. So there's A. 5 to what power is 10? So 5 to the 1st, 5 squared is 25. So 10 is in between those values, so it's between 1 and 2, but closer-ish to 1. That is 0. That is 1. 10 to what power is 5? Well, 10 to the 0 is 1. 10 to the first is 10. It's in the middle there between 0 and 1. So, E. For 7, let's see, any of these exact values? Yes, this is 3. Now for the rest of them. Log base 10 of 50. 10 to the first is 10. 10 squared is 100. 10 to the third is 1,000. So 10 to what power is close to 50 will be between 1 and 2. 150 will be between 2 and 3, but way closer to 2. 500 is more than B, but less than 3, so I'll put D in here. So since 150 is closer to 100 than 1,000. 500 is further away than 150 is, which is why I knew it was not as close to 2 as B is. Now 8, because all the bases and the arguments have the same base, like log base 3 of 3 squared, these exponents are your values. Because this is saying 3 to what power is 3 squared? Well, that's 2. So put those on your number line. All right, page 10. Based on your work so far with logarithms, determine whether the following statements are true, sometimes true, or never. If the statement is sometimes true, describe the conditions that make it true. Explain your answer. So for a sometimes, give me an example of why it is true or why it's not. We'll pause the video here and give you probably 8, 9 minutes to see how many of these you can answer. Okay, so for number 9, you should have said sometimes. And that is because if the base or the argument is a fraction between 0 or 1, so if B is a fraction between 0 or 1, then the answer will be a negative. Then the answer to the log is negative. For example, on the warm-up, we saw when this argument was 1/9, we had a -2 answer. Okay, number 10, log base b of x is not a valid expression if x is negative. That is always true. The argument can never be negative. X has to be greater than 0. Log base b of 1 equals 0 for any base greater than 1. That is always true because if we write that as an exponential, it's saying base to the 0 is 1. Well, anything to the 0 is always 1, so that will work. For 12, log base b of b is 1 for any base greater than 1. That is always true again. This is saying base to the 1 equals the argument, and that is a true statement. For 13, log base 2 of x less than log base 3 of x for any value of x. For that one, you should have said sometimes. And here's the examples I would give. So log base 2 of 1 is less than log base 3 of 1 because, that's not true. Those are both 0. So it's not less than, they're equal. That's not true in that case. If we do log base 2 of 10 and log base 2 of 3, log base 3 of 10, is that going to be true? I don't know. Let's see. Like, is it less than? So 2 to what power is 10? It's going to be between 3 to 4 because 2 to the third is 8. 2 to the fourth is 16. Now for 3 squared is 9. So this is between 2 and 3. This is bigger. So really, that's a greater than symbol, not less than. And then it could be true if we do log base 2 of a half and log base 3 of a half. Is that going to be equal? Is that going to be less than? So this is a -1, and this is saying 3 to what power is a half? I don't know the exact value because the 2 and the 3 can't be made into the same base, but it's going to be a bigger value than the -1 to make the 3 into the 2. So like, for example, if you think like -1/2 or -1/4, that this 3 to the -1/2 would be like the square root of 3 in the denominator, even though that's a 2. So this number is bigger than -1. That's a tricky one. Okay, and 14, log base b of b to the n will equal n for any base greater than 1. That is always true. If you write it in exponential form, the base to the answer will equal the argument, and that is a true statement. Oh, those are the same thing, okay. If there is time left in class before we start our homework, find a blank page and we are going to try some problems. Write these down with me. Log base 25 of 1/5. Log base 1/8 of 2. Log base 1/16 of 64. Log base 4 of 8. Log base 8 of a half, and log base 9 of 1/27. Okay, so these 6 problems give you about 6 to 10 minutes. See what kind of answers you can get. We'll pause the video and then I will show you our answers. This is saying 25 to what power is 1/5? You should get -1/2. You can put this 5 in the numerator by making the exponent negative. 25, I can make a base of 5 if I square root, so I make it a 1/2 W. So 1/2 W equals -1, so we get -1/2. 1/8 to what power is 2? You should get -1/3. And 1/16 to what power is 64? You should get -3/2. So for this one, I can make 16 and 64 both into a base of 2. doing that right? Let's see. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the, oops, fifth. Oh, 2 to the sixth. Okay, that's what so negative 4w is 6, divide by negative 4. We don't leave negative 6/4, so our answer, reduce that to negative 3/2. All right, for number 4, 4 to what power is 8? Well, 4 can be 2 squared. 8 is 2 to the third, oops, third. So you should get 3 over 2. For number 5, your answer should be negative 1/3, and number 6 is negative 3/2. So my work for those, for 5, 8 to what power is 1/2? Change them to a base of 2, and there's my negative 1/3. 9 to what power is 1/27? These can both be a base of 3. So 2w equals negative 3 when you solve is negative 3 over 2. Okay, now if there's any time left in class, your homework is page 11, number 7 to 16. Do it now. Do not pack up. Do not clean up. Do the homework. 7 to 16. Make the best use of your time.